Alrighty, so this is the second assignment using Python requests and regular expression modules to write a code that enables dot access to coefficient properties of chemical data exported from KimCAD using abbreviations given. I'm actually going to go ahead and just, when I get to that part, pause the recording and type them all up just to save both time and data. Because if it's too long, it just takes forever to upload. Oh, we'll get to that part when we do. So first we need to establish a dictionary for a shortcut. So we're going to do pip install .map. Let's see if it works. Excellent. This is not my first try. Okay. Then we're going to have to import all of the things. So we're going to need to be able to do requests, and we're going to be able to retrieve data from requests and take in information from an HTML file. So let's import requests. Nice. Import requests. We're going to import. Nice. And actually, I'm just going to. I'll do one. So we're going to import requests, regular requests, strings, is that it? No, it feels like that's not it. We're going to, oh yeah, .map. From .map, we're going to import .map, and then we're going to import our normal numpy as an np. All right. Actually, I think this needs to be the same. Oh, string. Good deal. All righty. So now that we're all primed and set, now we're going to need to set up the extraction to the single set of, like, we need to set up a method to extract single properties using shorthand correlation. So like molecular weight MW. So we're going to extract, and actually I'm going to extract single properties. And that's going to be equal to, so like, and I'm going to stop recording real quick so I can just type these out, and then I will read just for time and also data shake. So and normally I would not do that, but these were actually given the problem, so I don't feel bad. And like I said before, these are just part of the setup to extract single properties and make a guide of shorthand correlations so we can navigate a little bit easier later. Similarly, we're going to do the same thing to extract like the coefficient, the properties of the coefficient. So extract coefficient. And this will be something similar also. I think that there's two of these. It's not necessary. And I'm probably made a mistake or two in there, but we'll cross that bridge when we get to it. So similarly, we've got coefficient properties like vapor pressure. And like before, because these are given, I'm actually going to pause while I type these in to try to save some time. And also, again, data. All right. So, I'm going to look at this for a minute, and if it takes too long, unexpected ending. I actually have no idea what it means by that. First of all, I missed that. It's going to come up like excellent. Okay. So next, we're going to need to set. Okay, sorry. Important. All right, we need to set up the IP to extract the properties with the coefficients. That's what we just did here. So we've extracted the properties that are strings and shorthand, and we've extracted the properties that are coefficients as well now. So now it's time to get our data from GitHub. So we're going to get the chemical data. We're going to make sure that we want to get the raw file, because if we don't get the raw file, it's not going to work very well. So we're going to use the base URL, not base here, not the base here. You're going to import it as base. Just the base is fine, actually. And let me go get that. URL real quick. Boom. All right. Excellent. No problems there. And excellent. Close my tabs real quick. Tabs don't need to be open. You can leave them. So I've lost my train of thought. Okay, we're gaining access to the actual raw file. So now I think we need to set up that I'm gonna pause real quick because my brain is fuzzy. Okay. All right, so now we're going to, in the same line here, we're going to a determiner component that does not change. So we're going to make suffix from props dot the text. We want to name the compound that we actually want. So we'll start with the oldie but the goodie of water, and that's going to need brackets. And everything's in a quote because it's a string right now. It's actually coming from the file itself right now. So now we're going to create the compilation because we want to repeat this process over and over. And going to use the single props here to make a pattern and grab the desired components. You want to make sure to start with an R to get the raw string. So we want the single properties. And this is going to be where we're using the regular commands. We're going to compile. And we're going to need to start with R. This is raw file. And we need to, I mean, the reason the raw file is important is because if you don't take the raw file, things like slashes and things will be interpreted as like commands, like to go down to the next line, etc. Instead of, but we're going to be using those in the actual file, so we don't want them to be interpreted as not the data that we actually need. We're going to, the caret start and the caret start and the dollar sign in. So we need to make sure to give it a flag so it knows how to break up all that obtained information. So let's start with the caret. I can't remember if it's the V or we'll find out if it's not. That is supposed to be a plus. I'm going to do that. I've done that so many times already. I'm going to continue to do that. Let's hope it doesn't take too long to get it right this time, though. Ooh. I think that's right. Seems short to me. I feel like I'm missing things. I'm sure we will find out, though. Looks okay. Boom. Nope. For some reason that I have noticed that, like, even though it does not make sense for it to do that, going down to the next line will like kind of muddy up the code. What just happened? Oh, I can do a school full screen. I should be doing that the entire time. All right. So now we've got the single properties. We're going to move on to my brain is. All right. So that's the single properties we have here. We're going to move on to the coefficient, properties with coefficients. So and use the regular functions again. We're going to use compile again. Going to make sure to get the raw file, again. And here we go. Can you tell that I'm not a strong typer? I'm not used to using all these like / backslash brackets and stuff. Plus, for some reason, I've never gotten used to this keyboard. Nope. Nope, nope, nope. That is not okay. So I try to top. Boom. All right, so now let's get our errors. Excellent. Bad character range at position 16. So what I can tell, it's just I missed something here. Oh, right here. All right, we parentheses. Come on. There. And in parentheses. Here. And I think that's it. Excellent. And that one was good. Wow. I'm actually a little bit surprised about that. Alrighty, so now we want to set the text to the material we obtain and apply the correct expressions to that material. So test text. Excellent. And we're going to get the base plus, and we're going to use an example. We're going to use, because I'm honestly just afraid of changing literally, going off book too much. We're going to use water again. And excellent. Okay. All right. We need to use single props and dictionary to make the list of tuples. So we're going to do the single, I think, probably a property. No, not property P. Single prop, same prop. Yeah. Why does it remember that? Oh, because we're going to make a reference to the dictionary. And we're going to do a for here. No, font here, I think. Let's do, find all. All right, let's try it. We're going to get all our errors. Okay, so let's see what we got here. So response object attribute txt, the dot txt is not okay because it's dot text, not dot txt. That might be it. Nope, we got more. So same promise. PT is not defined. Yeah, I don't think I used that one. I think it's a different one. Use single properties P. Actually, I like single property better. Yeah, I do. I think I like single properties. Sing properties. And then code name. Yeah, that's fine. All right, let's get that now. Oh, we have to run this one first now. Excellent, excellent. All right. All right. So now, for each element in the list, we want to return only the first and the second part of the tuple, not the entire tuple. So we're going to make a for loop. X We're going to float that. All right. Let's try it. All right. Invalid syntax. Yep, that makes sense. That follows. That's fair. Let's try it again. Invalid syntax still. I just don't know why I have that. because it's not same prop, single prop, it's same prop. I wonder if you can tell that I've done this so many times. All right. So molecular weight here. All right, give me. I literally have no idea. I keep getting this error, and I cannot fathom what it could be from. I really don't. I've tried changing a couple things, but nothing seems to work. I guess I'm just getting a little bit. The only thing that changed, the only thing I've like gotten creative with is like I can't. I really don't know. So I might have to just restart the whole thing. So I did what I always do. Whenever I get stuck, just really stuck, and I can't figure it out, I just start over from scratch, which is time consuming. I didn't show that because I didn't want to make this video 2 hours long, but I did it all over again. So we're going to start back right from the point where we are down here. So we just got done. We've already extracted everything. We use the base. I'm going to say base URL just because I know, like, I'm concerned that like somehow the naming that I chose might have like this stuff is finicky for me and it's difficult for me also. So we're down for each element in the list. We want to return just the first and second values of the tuple. So we're going to create the for loop for that right now. All right. KV and the for does not be capitalized. For the KV and extract single properties. The items. All right. I'm going to float this. So we can the single properties. All right. Now, okay, so singe. So maybe there's L. Okay, is not defined. Single rows. Would hope that the L was in the correct position, huh? Excellent. Okay. Thank God. All right. So now we need to set the names. The name. So now we want to set the name as strings from the dictionary. So we're going to use the coefficient. Now we're going to pull from the dictionary. Coefficients. Find all plot. And we're going to find all text. Excellent, excellent. There we go. All right, what we got? Name test. The text. Ha, excellent. All right. I think that's old. Yes. Cool. So now I want to make a for loop to pull out and to split the text that we pull from here using the regular expressions, and I'm going to section off the full names and the short names and extract properties. So for full name, abbreviated name, there's two B's there, and there's no B yet. That's in the extract. Coefficient props dot items. Yep. All right. Now we actually want to split the data string. So coefficient values. Are going to be regular and split. Make sure you use the R because we're going to do the raw data file. String. String is nice. I'm going to do full name. Nice. Good deal. Now the full loop is going to go item by item for the coefficient and make a zip to fuse the coefficient of the information and the letters corresponding to it. So we can create a new one that just like you could type in just the letters and you get the coefficients, which is going to be good. So we're going to do another for loop, not capitalized, with the letters and the coefficients that are inside zip. Zip is a string. Inside the zip is a string. Uppercase. Coefficient values. Name. Name. Nice. Plus the letter. We're going to put that. All right. We don't need that there. I don't think we need that. We don't if we do that correctly. And in the dictionary, we can now assign the new zipped file by using .map. Boom. All right, let's go for it. What name string uppercase is not defined? Oh, crap. I remember there was something weird about it. Oh, okay. There we go. The Asahi. I think I spelled it wrong. Is it A-S-C-I-I? No, that's right. String. String. S-T-O, because it needs a string. Yeah, they need the T. Don't idiot. Boom. Excellent. We're going to add some more lines of code. I just like to have them there. That way that way you have them. So now we want to create a function that calculates the actual vapor pressure using the values that are in the dictionary. So we're going to define vapor. Ooh, did I have it for us? Define. No. Vapor. Nope. Define vapor pressure according to. Now we want to use the equation that we were talking about before in class, equation 106, was it? No, the equation for vapor pressure using the values. And okay, so it's P. Okay. All right, cool. So we're going to use the equation that we know for vapor pressure combined with the actual values that are in our dictionary to calculate the vapor pressure of any of the values that we have set up in the zip dictionary thing that we set up. Zip, the new dictionary with the zip included. So we're going to all right. Let's see if I can get this the first time. This time, it's been like the 5th time total. Just a second. Let me. All right. Good night. All righty. So all the values are going to come from the props. So we've got. We're going to first take the vapor pressure. Dot. And we're going to do the first vapor pressure that we get. And we're going to add that to the vapor pressure. There we go. B. Second vapor pressure divided by the temperature. It's going to be added to multiplied by the logarithm, not capital, just regular. Deal. There's 0 chance that I get this the first time. First time this time because we are on like the 8th time total. Times temperature, power of all right, what do we do? Keyword can't be an expression. Return EXP. Right. This requires contemplation. So I think I found out my problem. Finally, it's because frequently my plus sign requires a shift, or else it becomes an equal sign. God, please let this work. Thank you. All right, so now that we have created a function that calculates the pressure using all of the important components of the defined variable, we should theoretically be able just to say vapor pressure and put in some temperature, and it should be able to give us that vapor pressure. So let's try it at Just a change 273. No, doesn't work. All right. Object has no attribute PVPA. All right. Let's see. Time for more contemplation because I don't think this is going to be resolved anytime soon. Sometimes this works. Sometimes if I just go back through everything I've done and hit the play button, make it actually run each thing individually in order, it will sometimes resolve itself. No. All right. It had to be different. It has no attribute PVPA. So yeah, no, that's correct. Okay. All right. So I could not figure out why it was not working. So I redid everything again, not everything, but several things. And I'm going to go through all of them and we individually run them. Sometimes pulling them apart helps me also. All right. It worked once. Hopefully it will work again. So, last thing to do is check and see if our vapor pressure calculator that we created here using are those, oh no, wait, did I? Yes, that we created here actually works. Wait, where's my calculator? Did I accidentally delete it? Yep, I did. On option, I think. Unless I'm just going insane. Yes, I did. I know that. That's okay. I'll just write it out again. I'm going. Hopefully this will be the last time. So we're going to create our calculator again for vapor pressure. Using temperature. Turn. B. Yes. Take the component of props. Vapor pressure. A. That gets added to props. Vapor pressure. B, which is divided by temperature. And added to C. So double check it so I don't get used here. All right, nothing bad so far. So then multiplied by MP log base 10 T temperature. So add to D, right? T, I think. A, B, C, D, D. Good. All right. And then that is multiplied by temperature again. Take it to the power of deal. All right, now this is the moment of truth. Does it function? So where am I going to? Let's just do something nice and easy. 273. No. Okay, I can fix that. Hopefully. Let's put it operands type for .map and integer. Let's put operands type. All right, try running everything again. No. Okay. God. So I separated a bunch of stuff out before, and that seemed to have not worked. So now I'm putting all the stuff in the same cell, because for some reason, this kind of stuff likes to do that sometimes. And I honestly do not, I've gone through this so many times now, I honestly don't know what else it could possibly be besides something like that, because it is very finicky, and I'm not used to that. Like the fact that it cares about like how many spaces there are from like the margin is very odd to me. So I'm gonna put it all on one giant. I guess I should run it and make sure it's still working. Good deal. Put it all in one giant code. All right. Wait, no, that was the one that was. They even tried the original text to see if that would work, and it did not. All right. Let's do that. No, so it's still saying that it's not defined. So I really honestly just don't know what it could possibly be. Okay, there it is. It finally worked after, so I guess it like having it all in one giant drive worked, where separating it didn't, even though separating it was a lot more clear for me. Jeez. Nice. No, I'm pretty sure that's correct. I could have gotten something wrong here. So I'm going to check it real quick against known. So room temperature. And it is water. And not water. Excellent. 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 All right. Well, there we have it. It only took, hopefully, I wasn't recording for too long. It took me several hours, but excellent.